Okay, if we want to solve a differential equation that looks something like this, we want to get it in a form that looks like this. Y prime plus P of X times Y, where P of X is a function of X only, equals Q of X, which is another function of X. And we can do that by dividing every term of the original equation by X. And that'll give us dy dx plus 2 over x times y equals sine of x over x squared. And now if we can figure out what the integrating factor is, that will be right here. The integrating factor is e to the antiderivative of p of x. And the antiderivative of p of x is 2 ln of x. But if by using the power property of logarithms, I can move that 2 up front. And so the antiderivative is ln of x squared. And so e to the ln of x squared, e to ln of anything is the anything. So there's your integrating factor right there. So I've multiplied every term of this equation by the integrating factor. Here's x squared times y prime. When I take x squared times this term, one factor of x cancels out. I did that backwards right here. This should be 2x, 2xy equals, and I take x squared times this, I just get the sine of x. Okay, and now I take the antiderivative of both sides, and the whole point of getting this form is that this is really the result of applying the product rule to the expression integrating factor times y. Every time, integrating factor times y. And over here, the antiderivative of sine of x is negative cosine of x. Here we finally introduce the constant of integration plus c. Divide by both sides by x squared. And there's the general solution to the original equation. And here's a way to convince yourself that that's true using Desmos. Here's f of x equals our general solution, where c is an arbitrary constant. You could use this slider to change the way the graph of f of x looks. Then g of x is the derivative of the original function. And now I can write x times g of x plus 2 times f of x and compare that with the graph of the sine of x over x. And if they're identical, that means that this indeed was a solution to the original differential equation. Okay, there you go. Hope that helped. If you have any questions, post a comment.